Okay, this is a video recording of Lesson 3 titled Access Modifiers and Constructors. And as is the case with most lessons in this course, I will not be comprehensively telling you everything there is to know about that topic. So in this case, I won't be telling you everything there is to know about access modifiers and constructors, but rather I'm just trying to introduce them in an intuitive way and give you an idea of what these language features are for. And I want to make sure I tell you enough about them in order to do well on your homework assignment that will involve these as well. Okay, we'll skip these slides for the YouTube video. In the course, we're still right here. In particular, with Lesson 3, we're going to keep building on C# language features. Okay, so where we left off, from where we left off, hopefully this program should make sense to you. So we have a stat variable. The stat variable is of type thermostat, and as with most thermostats, it can read a current temperature. So we have a current temperature of 65, and then it has a goal temperature. And then all you do with the thermostat object here is determine if we're heating or cooling, or if we're not doing either of those things. So a simple program, and this is the class. This is what defines how thermostats work in general. Okay, so we have our two properties, current temperature and goal temperature, and we have these two methods, whether this thermostat wants to be heating or whether it wants to be cooling. Okay, so this should make sense from where we left off on the last lesson. Okay, but we have a problem. So with this, we are able to set a goal temperature that's arbitrarily big, arbitrarily small, and that's not good, right? I don't want to pay this heat bill, to heat my house to the temperature of the sun's surface, right? That's what that number is. Temperature of the sun's surface in degrees Fahrenheit as well. So we're able to kind of misuse our thermostat object by being able to set it to a really high temperature. Now, if you're wondering, who's going to do this? Who's going to set their thermostat to 9,941? Just get creative with it. Think maybe someone was using this thermostat, didn't know it was measured in Fahrenheit. Maybe they're using some other unit of measuring temperature. And 9,941 is a perfectly comfortable temperature, in their unit. Whatever they're using. So get creative, because things like this happen where values that don't make sense for what we're trying to do end up being used in the program. Okay, so we need to solve this problem because this is just outright dangerous, right? We can't have a house be heated this hot or whatever is this thermostat is controlling. Okay, so restricting the user, right? So we need to ensure that the thermostat can not have a value that's out of a valid range. Never have a value that's out of a valid range. And so the two C# features we'll use to do this are access modifiers and constructors. There are other ways we could solve this problem, but for the sake of introducing access modifiers and constructors, we're going to solve this problem using those two constructs. Okay, so an access modifier controls what parts of a program can access the thing in question. And I'm using thing in question, I'm being vague intentionally because these kind of access modifiers pop up in all different places in the language. They pop up on classes, they pop up on properties, they pop up on that get set syntax, pop up on methods. So there's all sorts of things that they control, but the interesting thing is it's the same 4 words no matter where they're popping up: public, internal, protected, and private. These are the 4 access modifiers. And to make it even simpler, at this point in the course, we are going to consider that internal is the same access modifier as public, and protected is the same access modifier as private. So really all you need to know is there's public and there's private. That's all you need to know for now. If you see internal, think public. If you see protected, see private. Okay. All right, so let's see how these work here. So here we have our thermostat class. It's the exact same thing, except I've thrown this private word right before the word set. And because we marked it private, that means only code that is within the thermostat class can modify this variable. Okay, or I shouldn't say variable, I should say property. Only code that's within this thermostat class can modify this property. And another way you can think about it, if you'd like, is any code that is within the curly braces of the thermostat class. That code is what can modify this goal temperature. But because Git is not private, anyone can read the goal temperature on your thermostat. Okay. Okay, and so that means that only code with inside the thermostat class or the squigglies of the thermostat class is going to be able to set this goal temperature. Okay? So the exact consequence of what we did by adding that private set to the goal temperature property is that this line of code is no longer valid, right? We're back in our main program in the main method, and we can no longer set the goal temperature to any value at all. In fact, we get this error, red squiggly signifying we have an error. And if we hover over the error, it'll say the property or indexer, just see property. We don't have to worry about indexer. The property thermostat.goalTemperature cannot be used in this context because the set accessor is inaccessible, right? And Visual Studio is kindly showing you this property too. It's like, hey man, I know you have this goal temperature property, but the set is clearly private, so we can't modify the value of the goal temperature here in this part of the program, right? We're in 2 separate parts of the program. This is the program class containing our main method. This is the entry point of our code. This is what drives what our application is going to do. The thermostat class, that's a completely different location of code. So, that's because we're in 2 different parts. That's what the private set is saying. So if you're in the thermostat part, you can change this. If you're anywhere else, including the main program, you cannot set this value. Okay. And so we're going to have to remove that line. We cannot set the goal temperature from outside of the thermostat class. So we have to remove that line, and we're going to need to find some other way to set our goal temperature to 70 degrees. Right? We don't want to give up. Right? We want to conquer through and be able to set our goal. So we need some other way to do that. Okay, so we're back in the thermostat class, and what I've done is, well, first I've collapsed the isHeating and isCooling methods. Right, the code is still here, but I've collapsed that code so that we don't have to worry about it since we already know what that code does. But more importantly, what I've done is I've added these 2 methods: increment goal temperature and decrement goal temperature. And what I'm trying to do is emulate how an actual thermostat works. Right? Actual thermostat, you walk up to it, you press the up arrow, and your goal temperature goes up 1. Or you press the down arrow and your goal temperature goes down 1. So this is how an actual thermostat might work, right? So I've added these methods to emulate that, okay? Increment and decrement goal temperature. And if you look in these methods, we're going this dot goal temperature plus equals 1, right? So we're reading the goal temperature, saying whatever the current value of the goal temperature is, we're adding 1 to it, right? You all know what plus equals 1 means. But the important part is we're changing that value. We're changing the goal temperature. And that's okay because we are within the thermostat class. Okay, we are within these curly braces. So that's legit. We can do that. And the other thing you'll notice in these methods is we have some restraints. We have some restrictions on exactly how this thermostat works. So we can say, this dot goal temperature must be less than 80 degrees in order for us to want to increment that goal temperature. Okay, in order for us to be able to increment that goal temperature. And same with decrement. We must be greater than 60 degrees in order for us to decrease that goal temperature. So, by using these methods, we're able to restrict the range that we can set goal temperatures in. Okay, and we're more precisely emulating how a thermostat works, at least an old school thermostat. Okay. Okay, so now we're back in that main program, and we kind of have these new instructions for how a thermostat works. So setting your goal temperature gets a little weird, right? We got to do this kind of while loop thing, stat.goal temperature, and we keep running this loop while the goal temperature is less than 70 degrees, and we keep pressing the up button, if you want to think about it like that. Keep incrementing the goal temperature until it's finally set at 70 degrees. So this is kind of how we have to interact with it in our code. It looks a little weird, the fact that we have to set this while loop up, but this is how a thermostat more accurately works. So now there's still an issue, right? There's still an issue. And that is when this thermostat is first created, what is the value of that goal temperature? Right here I wish I had line numbers here, but right here on this line, what's the goal temperature? Well, we can use a debugger and we can look, right? So I've frozen the code right here at this line, and in the debugger we're able to inspect what the values of stuff is, interactively. So I've hovered over stat, and its current temperature is 0, right? We're about to set the current temperature to 65, right? But the goal temperature is also 0. And what we said earlier is we never want our thermostat to have a goal temperature that's out of the valid range. Never. That means including when we first create it, right? Because what if we don't touch the thermostat? Well, then it's going to be set to 0 degrees, and that's also an expensive electricity bill, right? So this is where constructors come into play. So constructors contain the code for getting a newly created object in a state where it's ready to use, okay? A newly created object. So what are we talking about here? We're talking about this new keyword here. So the new keyword signifies that we are creating a new object. In particular, we're creating a new thermostat object. Or another way you might hear it is we're creating a new instance of a thermostat, okay? So new keyword, new object. And that new object is being assigned to this variable stat, okay? So if we want to access or interact with this new object, we should go through this stat variable. Okay. Now, what's also true is constructors are a special kind of method that gets called as soon as an object is created. Before anything else can happen to this object, the constructor, the code in the constructor, or the constructor method must get called, and that code must get executed. Okay, so now you might be wondering, what method are we talking about, right? So these parentheses that we've been putting at the end here, this is the call to that constructor or that special kind of method, okay? So we have been doing it. We've been putting these parentheses here, but you know, they've been magical until now. Okay, so now let's revisit the thermostat class, and you might be wondering, what method, what constructor? I don't see anything here, and so the answer to that is all classes come with a default constructor that does exactly nothing when a newly created instance of that object is created. So you know, there is one, but for simplicity, you don't have to put it there because it's going to assume if you didn't put a constructor in your class, that means you don't want anything in particular to happen when you're going to create a new object, in this case a thermostat object. Okay. So now I've added that constructor for the thermostat that contains the instructions for getting the thermostat in a condition where it is ready to be used by other parts of the program. Okay, so let's break down this constructor, right? It's these 4 lines right here. 2 of those 4 lines being curly braces. So public thermostat, open close parentheses. So this is if we think about the constructor as a special kind of method, we said before that all methods need a return type or need to be associated with a type, and we don't have one here. So that's for simplicity. You can read that as public void thermostat, right? Void as in we're not returning anything when we're creating a new thermostat. We're just trying to get it in a condition where it's ready to use. Okay, and the name of the constructor needs to be the same name as the class. Okay, and that's how we know it's the constructor, because it has the same name as the class that it's a part of. Okay, and then here are these open close parentheses. Okay, that map to the open close parentheses we saw on the other end of it. Okay, so now finally, these are the instructions to get it within the curly braces of the constructor. These are the instructions for getting the thermostat ready to use. Okay, and that is simply just setting the goal temperature to something that's within our valid range. Okay, so that means when we create a new thermostat, these instructions are going to be ran. It's going to set the goal temperature to 60 degrees, and we'll be good to use the thermostat from then on out. Now, if we run this program and we freeze it and we inspect it at the debugger now, we'll see that here on this line, we're creating a new thermostat, and we're inspecting it on the line after. We're about to set the current temperature, but you can see the goal temperature is already at 60 degrees because the instructions for making a thermostat and getting it into a condition where it's ready to use have already been executed. So that's how we got the goal temperature is equal to 60 degrees. Okay, and so the problem is solved. Okay, so a few general rules I want to say to you about access modifiers is that classes, properties, and constructors should all be marked as public. Okay, so here's your class, public constructor, and then public property. Okay, so this is not universally true that these should always be this way, but where we are in the course, generally it's going to make sense for these to all all be public. Where you have some flexibility is with the methods and with that set at the end. Methods and the set operation on a property could be either public or they could be private. Okay. And so by default, if you don't put anything here, it's public. Actually, you can't put the word public here because by default, get and set are the same accessibility level as whatever you put on the left here. Because I told you we're going to be putting public for all of our properties on the left here, these are public. Okay. Unless you put the private word in front of them. Okay, so here's an example of the private, right? So we saw the private set here, goal temperature, private set, and methods, you can do the same thing. So this is some derivative of the thermostat class where we have a public method, get status, that tells you, what state the system is in right now. Are we heating? Are we cooling? Are we not doing anything? And the private methods that, so the public method is calling these private methods to help it do its job. So we can make private methods that are only accessible from other methods that are in the class. Okay? Okay, so some more about constructors. So because I said constructors are a special kind of method, that means they can also have parameters just like a method can. Furthermore, classes can also have multiple constructors, but the key is that each constructor must have a different set of parameters. Okay, so let's see an example of that. So here is another derivative of the thermostat class where we have the constructor we just saw, right? So this constructor takes no parameters. That's why we just have open close parentheses here. But we can also add another constructor that has a parameter here. So open close parentheses, and just like a method, we added this parameter, starting goal temperature of type integer, and we can assign the goal temperature to the starting goal temperature. Okay, so multiple constructors on this thermostat. And so if we see how that looks, imagine you have a program here. It has a home thermostat and a car thermostat. Home thermostat, we don't care about. We'll just say, whatever the default starting goal temperature is for our home thermostat, I'm good with that. For our car thermostat, we're able to call the constructor that accepts an integer as a parameter, one integer as a parameter, so 70, and the result of that is that when we create this new thermostat here, it's going to have a current goal temperature of 70 degrees. Okay. Okay. And then I'll do a short demo loosely about this. Okay, so for this demo, I just want to show a few things that are going to be helpful for the homework assignment and in general for getting exercise code onto your machine. So here I'm on the Azure DevOps platform right here. I'm in our public project, and if we go to repos and files, we can click this drop down here, and right, these are where all our exercise solutions have been going. And for lesson 3 right here, this isn't really a full exercise where we have some problem we want to write code for. It's more I just want to show you some things. We have this code here. So the thermostat program, and then now we have 2 files. Okay, we have the main program and then that thermostat class. Plus we have all these other files that are associated with this project that Visual Studio auto-generated. And so we're getting to the point where it's going to be difficult to be copying and pasting this code from the internet into your local Visual Studio environment. So this is where we're going to learn about Git cloning. Okay, I'm going to show you what it looks like to clone a repository in Git onto your local computer. So what you'll want to do is you'll want to pick out a folder on your computer. So I like this folder. This is where I put all my Git repositories. So C users, my username, source, repos, and then I have a subfolder just for this class, just for repositories related to this class. So this is the folder I like, but you can put it wherever you want. And I'm going to go ahead and copy this, and then I'm going to launch Visual Studio. Okay. So now I want to, in Visual Studio, we've been creating new projects and just copy and pasting. Now we're going to clone a repository. Okay, if we read the description, get code from an online repository like GitHub or Azure DevOps. This is exactly what we want to do. So clone a repository, and in the path right here, I want to put this right here. It's going to error, but that error should go away as soon as I do this next part. So I need to put the repository location in here. So go back to Azure DevOps and I'm going to go back to files here. So this is, we're still in the thermostat, lesson 3 thermostat repository. I'm going to click clone, and it's going to provide me this URL here. So I'm going to copy this URL, and I'm going to go back to Visual Studio, paste it in here. Okay, it doesn't like this still. So it wants a folder here. So it wants to make sure whatever folder you're putting this code in has nothing in it. So if I just enter a new folder name, lesson 3 thermo, it's going to create this folder on my machine and put this code in here. So let's watch this happen. So I'm going to click clone. If I go back to my file explorer, you'll see it created this folder, lesson 3 thermo, and it put all the relevant code in there. Okay, so now we have it open in Visual Studio. That it kind of just automatically opened. But what I'm going to do here is close Visual Studio to show you, how do you get back to this repository in Visual Studio, in the next session, the next time you're working on it. So I'll close Visual Studio, and I will go back here. So I'm in my repositories folder. I want to open lesson 3 thermo. And you'll see this solution file, Thermostat Program.sln. Okay, this is a Visual Studio solution file. If we just double click this, Visual Studio will open. Okay, and all our code is still here. If I open program.cs, this is exactly what was on the website or on Azure DevOps and the Thermostat Class. Okay, so that's cloning. That's if I have example code in Azure DevOps and you want to get it, you can clone the whole repository. All right, so now the next thing I want to show here that could be helpful for homework 1 is using the debugger. So I had some screenshots in the slides of the program frozen and showing current values of variables. So what you can do with the debugger is you can set a breakpoint. So you set a breakpoint by this gray bar, this vertical gray bar on the left-hand side. You can put a breakpoint on a line. So put one on line 8, and then when I run this program, just by clicking the button as we do usually, right, the program freezes right there. It's frozen on line 8. Nothing else is going to happen until we provide further input. Okay, so we're frozen on line 8, and we can hover over this stat variable. Okay, now stat's an object, so it has multiple things associated with it. So you have to click this hierarchy arrow or this expand arrow, and now you can see the variables or the properties associated with thermostat. Okay. Now, if you want to just, say you just wanted to pause the program and inspect, and then you want to move on, you can just click continue up here, and then the rest of the program will run. Okay, so now what else? Let me add the constructor back in here, and we can go this dot goal temperature equals 60. Okay, so just adding that back in here. That was in the slides. And I'll run it again and inspect stat, and you can see now the goal temperature when a new thermostat is created is right here at 60 degrees. All right. So now there's two other operations we need to talk about. We need to talk about step over and step into. So step over, which is F10 for short, as a short key shortcut, says whatever the line of code I'm currently on, execute that line of code, and we'll move to the next line. Okay, so we're on line 8, and current temperature is 0, and now I want to just execute line 8, so I'm going to go step over, and now if I inspect stat, then we can see the current temperature is 65. Okay, so that's all good. Stepping over just says whatever the line is, just execute it, and let's move to the next line. Step over. Okay, now step into is useful for example, method calls. So here we're calling increment goal temperature, and we could step over and just say we could do step over and just say execute this line and let's move on, or we can step into. All right, and that's diving into the code that makes up increment goal temperature. So we do step into, which is F11 for short, and boom, we jump on over to this thermostat code. Okay, and so now we're in here, and we can keep doing the same thing. We can step over. If we were calling another method underneath, we could step into that and keep stepping into stuff. But these aren't method calls here, so we can just step over, and you can see again here, goal temperature 60. We step over, execute this line, and now it's 61. Okay. Couple other things I want to show. So increment goal temperature, if I take increment goal temperature and set it to private, right? You see we get an error right here. Okay? So just wanted to interactively show that. And additionally, so let's set it back to public. Let's say I have not written this line of code yet. So I'm going stat dot current temperature, goal temperature. So these are the stuff that's available for thermostat, right? So these are the properties, and here is the method decrement goal temperature, and here's the method increment goal temperature. We got methods is heating, is cooling, right? So we can see everything that's available to us about this object. Now, if I hop back over and I set this to private, you'll notice in IntelliSense, now let's open the IntelliSense window again, there is no increment goal temperature, because that's not available for the outside world, this outside code to call. It's not a method you can call because it's private. So just wanted to show you that IntelliSense is interactive with these public and private kind of language features here. Okay, and that's all I needed to show here.